Welcome back to the CSUSB Advising Podcast. My name is Matt Markin, Academic Advisor, and on today's episode, we're going to learn more about the physics major and astronomy minor. So today, Professor Matteo Crismani joins us to tell us more. Professor Crismani, welcome.
Thank you. Thanks for having me.
Yeah, great for you to be here. And so before we start diving into the majority of this podcast episode, tell us a little bit about yourself.
Yeah, sure. So I'm a Southern California native, born and raised in LA, and I did my undergrad at Santa Cruz. Got really interested in astronomy while I was there. I was actually a politics major to start with. Decided that I absolutely hated that and found this real appreciation and fascination for both math and physics. And so I started to pursue that. I went to grad school in Colorado, and then I did a postdoc in DC at the NASA Goddard Space Flight Center. And then I saw this opportunity to come back to California, which I obviously love. A lot of my family's here. And so I jumped on that, especially being able to work with the students that we have here and have this very tight-knit, very cool department that we do have. My research in particular is into the Martian atmosphere. So even though we're a physics department right now, we're currently petitioning to change the name to Physics and Astronomy to sort of reflect the fact that we do have 7 faculty members and a little bit close to half are actually astronomers. And so there are people in our department who are working with comets, with galaxies. And like myself, I'm working with Mars and planetary atmospheres. And so they just made me the director of the observatory. And we are now, we have an on-campus observatory, and we're hosting public observing nights, which are every third Thursday. And I think it's a really great opportunity to both interact with the community as a whole and to show off how fantastic some of the telescopes that we have, these new telescopes that we've purchased, and some new ones that we're getting installed later this semester will be for as a training tool and as a community outreach tool in getting folks interested in astronomy and physics as a whole.
Yeah, that sounds exciting. I mean, and congrats on the new director position as well. So another hat that you get to wear.
Yeah, just more emails, really. So,
yeah. But and I think it's kind of like what you're saying too. The school is growing. And it's nice that we're advancing where we can. And so I hope it works out with changing the name of the department as well. And so, kind of going into that, students might be interested in what is this physics major? How would you describe physics?
Yeah, physics for me, as a concept, as a field, really is looking at the physical world around us and trying to come up with rules about how it operates. And these are trying to be boiled down to the most simple way of explaining them, and then adding on little caveats that just make it a little bit harder every moment. So how does a ball fall is the easiest way to think about it. But then how do stars move around one another? How do planets form? These are more complex versions of that same question. And the physics major itself is sort of multifaceted because you were learning about all of these different phenomena. You're learning about light and optics. You're learning about how waves propagate. You're learning computational techniques and how to do data science. You're learning how to build objects in the electronics lab. And you're also learning all the math that goes behind this. And that can be really daunting for some folks. But I think once you see that math is sort of existing all around us and it's more of a representation of the world around us rather than something to be balked at or to be afraid of, it's a tool to help us understand the complex phenomena that we see.
And then with that, with the department, you also have the minors. So you have the physics minor, and then there's also an astronomy minor. And so can you talk about how would you describe the physics minor, the astronomy minor, and maybe what the difference between doing the bachelor's degree is versus the minor?
Yeah, I mean, they consist of different coursework. So all of the choices that you'll make along the way, let's say you're interested in physics, but you're not really sure what you want to do yet. You might, for example, just declare physics at the beginning and then decide that you want to focus more in on the astronomy, or you want to focus more in on applied physics or something like that. And it's going to really depend on what kind of physics classes you end up taking. So if you take the astronomy minor, for example, you will end up with a lot more astronomy classes, whether that's planetary science, whether that's galaxies, observational. Whereas if you go into the applied, you're going to probably be building more stuff in the lab. You're going to be in the electronics labs. You're going to be in there doing data acquisition type stuff. where you're going to be physically creating the objects that you're using to collect the data. So it's really fun. And we have a huge set, even though it's a small department, we have a huge breadth of classes that you can look into that will sort of feed these different skill sets that we're trying to get our students to come away with, which are mathematical skills, theoretical skills, analytical skills, interpreting that data, creating the data from the perspective of building the things that we're going to be creating, as well as communication. We really want to focus on how do we get our students out there into the world so that they can participate with one another, whether that's teaching, whether that's going on to be a professor or to go into industry as a whole.
And then with the bachelor's degree or with physics, there's the BA and then there's the BS. So if a student's like, I want to do physics, but maybe I'm not sure, should I be doing the BA? Should I be doing the BS? What would be your suggestion to that student?
I would say if you're interested, definitely come talk to one of us. And what I mean by that is it's really very personal. It's going to depend on what you've taken before, how well you've done in your classes, what your goals are. And so the reason why we're on the advising podcast is because I want to be able to encourage folks to come either talk to an advisor, either in our department or at the advising center as a whole, to really be able to make that decision. They're very subtle differences. And, when it talks about going to grad school versus going into industry, the difference between a BA and a BS is a little nuanced, but not something that's going to change your entire career.
Yeah. And then speaking of careers, I mean, that's some questions that we get a lot too. Is like, well, what can I do with this major? What have other graduates from the physics major have gone on to do?
Yeah. So the nice thing about physics as a whole, it's generally very applicable. As I mentioned at the outset, you're trying to understand the world around you. And it turns out that is really helpful. So I have, I've been here for a couple of years and I haven't seen a lot of students yet. I'm not 30 years into the department. I'm only a couple of years into the department, but I have lots of friends and I've watched them either start in physics and move out of it or graduate with their PhDs and go on to do something else. And I think there's a common misconception that maybe only physicists go into academia and that they only become professors and that that's all you end up doing with a physics PhD or with a physics BS. And that's simply not the case. In fact, a lot of our students, they're going to go into industry. They're going to teaching. So for example, if you want to be a high school teacher, that's a very important job right now as we try and build the next generation of scientists at every level, whether that's being an educator, whether that's going into, say, data science. That's something that folks don't really think about a lot of times. The types of data sets that you'll work in, for example, in astronomy, where you're looking at these huge data sets and you're trying to understand them with computational techniques, is a perfect laboratory for then going into something which may seem, quote unquote, more applicable in a daily life, like maybe resource utilization by electrical grids. They have a correspondence there in the same techniques that they use. And lots of folks maybe will go into something that's more specific. So you might start with, say, a physics engineer and end up in like a biophysics type role where the types of techniques and the tools that you're learning can be directly applicable. And I think a lot of people maybe are daunted by the idea of a PhD. You don't have to get a PhD. Lots of folks, for example, will go into industry right away and they'll find themselves very successful. And you'll go from, oh my God, I'm a student to a real professional right out of the gate.
Yeah, no, awesome. And then let's say, there's a student that I'm interested. I don't know if maybe I want to do it as my major or not. Can I do a GE class that in physics? How would you talk to that student?
Yeah, so I mean, personally, I would tell them to take my Astro 1000 class. I'm a little biased in that regard, but let's say you're curious and you really want to, take a GE class or something of that variety. We have a number of not only the intro astronomy type classes, but we have intro physics classes too. And there's physics in the modern world. There's introduction to physics. There's what's the more recent one I was looking at? Pop culture physics is a great example. And these will just give you a little flavor. And I think one of the things that I'd say is like, if you've always like maybe watched YouTube videos, been like, wow, that sounds really fascinating. I would love to sit down and see if I can really absorb that material. Give it a try. Have some conversations about whether or not we can work that into your career path, because you can take a couple classes and you might find, like I did in undergrad, that you, one, have a natural knack for it, or that you just can't stop studying it. I mean, once you start to see the world around you through the eyes of physics, it's really hard. You get addicted to it.
But yeah, just like you're saying, like there's a list of those classes that could count as GE classes, potentially double count for one of the requirements if they choose like the major or minor.
Yep.
But even if a student is like, you know what, I don't want to pursue the astronomy minor, I don't want to pursue the physics minor or major, they can still do like some of the lower division science for the GE requirement, or even some of the upper division. So whether you want to do like astronomy 1000, or you also have like the astronomy 3000, life in the cosmos, there's definitely other general ed classes that they can get exposed to that, correct?
Yeah, that's definitely the case. And you know, let's say you're a computer science major and you, for example, you're curious about computational physics as a whole. Well, we have students, sorry, that happens to be this book right here. We have students who come over and, you might be interested in one thing, maybe your bio, but you're really, really curious about how life forms in the rest of the universe. We have a class on that. And so there's this nice back and forth between the different departments where, as long as you have the right prereqs, you can take any of these classes, and I think they're really well suited. Some of them are more overview, and that's fun if you just want to sort of dabble in and get interested in astronomy or get interested in physics. And some of them might, change the course of your college career. So.
Yeah, and I will say sometimes, they might go in thinking one thing, and I just want this for my requirement, and then they have a great professor, let's say like yourself, and then they change their mind. They're like, I want to go down this path now.
That's always my goal. I always want to see if I can convince folks to switch over. And so, that's the fun thing about teaching, right? Is that you get to share your passion. And I think a majority of our professors are very passionate. In fact, we're growing. We're making a hire this semester, and we're going to add some more folks, hopefully in the next couple of years. And with that hope, we're going to continue to grow the department.
Yeah, absolutely. Now, Dr. Crismani, I'm sure, there's misconceptions that people might have about physics or astronomy, or both. So are there any misconceptions you've heard that you want to dispel?
Yeah, absolutely. And I think the primary one is like, what does an astronomer look like? What does a physicist look like? Who is a physicist? Who's allowed to be a physicist? And I think that's one of the most dangerous ones that we see. These ideas about only a certain type of person can do physics or astronomy. You have to be really, really good at math, and like, oh, you wouldn't be able to succeed because this is your background and this, that, or the other. And I think that that's really not the way that I've found a majority of my field. Physics and astronomy, both at a professional level and as an educational pursuit, I found is very diverse. I found that it has a variety of people, and I think that makes it stronger. It has different groups of people who bring to the table their individual skill sets, and their humanity as a whole is greatly respected. And so you come into it, you say, well, I learn in this way, and I think maybe I would be terrible at math. Well, it turns out that might not be the case. But maybe the way that, this one class was taught in the past has scared you, give it another try or have a conversation, because the way that even education reforms are going on is to acknowledge that people are different types of learners, and that gives more opportunity to a different variety of people.
Yeah, I love that answer. And let's say with your department, are there any resources that your department offers, any clubs that a student can join, tutoring if they need help, scholarships, anything like that?
Yeah, absolutely. So academically, we have tutoring. There are clubs that we are trying to get back off the ground after COVID. So there is a physics club, and I'm trying to get an astronomy club separately up and running as well. But there's also fun scholarships. And so from a perspective of both, including, not fun scholarships that exist that help to financially support our students, as well as research opportunities. So just the scholarships for a moment. There's CalBridge, and that's a wonderful opportunity to link between the CSU system and the UC system. You get a mentor from both, and they help you walk through the process, hopefully gearing you up for a PhD program. We have research opportunities through the Center for Advanced Functional Materials. including they have partners that we can send to. We just sent some students to New Zealand for the summer, so you can talk to them about how fantastic that opportunity was. And we have research opportunities in the department as well, which is sort of a fun way to think about how you could participate in research even at the undergraduate level, which includes, one, being financially supported in part, but also having a very unique type of educational experience, because the type of education you get through the research itself is much deeper and much more personalized. Now, our classes are already small. We have like 10, 20 person classes. So you're already getting a really great education in the one-on-one sense, but having a research advisor who could show you exactly what you might want to be doing and get a little taste for it before you jump into, say, this is what I want to do for the next 10 years of my life, is a great experience.
Yeah, and I think the smaller class size is a great selling point, especially because sometimes I'll hear from students where they're like, I wanted to ask a question, but like 20 other students had a question. So, I didn't get a chance to, or I didn't feel like, maybe my professor knew what my name was, so this definitely helps out with kind of that sort of like that one-on-one or more personal connection with the students.
Yeah, and I talk to a lot of folks too who are sort of surprised. They say, how can you get your classes that small? And it's like, we happen to have a really nice department at the moment, and we're hiring more professors, and we have a very good staff, both instructors and the support staff in the office here, all of who can give you really great personalized attention. And so, yes, maybe the very first class that you take, say the Gen Pop class, has 50 people. Okay, I'll admit that those ones always have a little bit more than normal. But when you get to computational, you have maybe 15 people, 16 people. And that provides a really great opportunity for me to really get to know you, for you to really get to know the material.
Yeah. And then, so let's say a student is, hey, I'm interested in astronomy, I'm interested in physics. They meet with one of us in advising, and we want to be able to connect them with your department or with someone. What's the best way to do that?
Okay, maybe there's not really one best way, but I can give some options here.
Absolutely, yeah.
So there is, our office staff. We are located in the PS building on the first floor, and so one of the easiest ways to do it, just swing by. You can. A lot of times the doors are open. That means you're welcome to come in and have a conversation with us. In particular, at the end is our office staff, Maureen Murphy, and then our department chair, Javier Turner. And, they're great to have a conversation with and sort of introduce yourself to. All of our emails are also found on the CSUSB website. Email us directly if you have any questions. We can either put you in touch with someone who can answer that more, or we can set up a Zoom session. We can talk about your career potential, any of those.
Yeah, sounds good. Well, a lot of useful information on this episode. Dr. Crismani, thank you so much for being a guest.
Yeah, thanks so much, Matt.